Students, I am Sheetal Dave from St. Elizabeth School Anjar and I am teaching you 9th standard mathematics chapter number 1, that is a number system. Now exercise 1.45, classify the following as a rational or irrational number. Now in the previous videos I told you product, sum, product of two rational number gives what, product addition of two rational number gives what. This all properties I discuss with you. Now it's an application, means we'll use it. So first of all, the question number 2, that is first is 2 minus root 5. Okay, so we have to identify whether it is a rational or irrational. Now see, this 2 is rational number minus root 5 is irrational number. And I told you, if you take one rational and minus irrational number, okay, what is the number? That is the irrational number. Why? Because 2 is a whole number and root 5 is non-terminating, non-recurring decimal number. And therefore, its answer is going to be irrational number. So that also you can write the rational number, okay, minus, what is irrational? Non-terminating, non-recurring decimal number. And therefore, its minus will be what? Non-terminating, non-recurring decimal number. And therefore, the answer is what? It is irrational number. Okay. So, this is the answer of the first question. This is rational, this is irrational. One rational, one irrational gives you always irrational number. We'll move to the now second one. So, what is the second number of question? The second number of question is 3 plus root 23 minus root 23. Now see, first of all, I want to explain you this type of a number, root numbers. So these root numbers, when we plus or minus, the same way we can cancel them as we are cancelling other numbers. Simple example I will take. For example, you have a 2x plus x minus x. This type of expressions are given. What you are doing? These all are like terms because the degree of x is 1, degree of x is 1 and degree of x is 1. So this is x plus and this is minus will cancel. So your answer is 2x. The same way when, see, this is root 23 and this is minus root 23, means they are like numbers. These are like numbers. So the whatever method we were using for the variables, the same method we can use here. So let's know how to cancel it. So equal to, now we'll open the bracket. This is root 23 minus root 23. Now this is plus root 23. This is minus root 23. Will be cancelled out. So your answer will be 3. And we know that 3 is a rational number. Okay. Now the third one we'll do. We are going to discuss now third question. So the third question is 2 root 7 upon 7 root 7. Before I go to explain this, the small number I have to explain. What do you mean by 7? 7 is equal to root 7 into root 7. Okay. In the next exercise, I am going to explain why it is like that. But always remember, 2 root 7 makes 1 7. For example, 5. So 5 means root 5 into root 5. Suppose I write 3. So it is root 3 into root 3. Okay. So in short, we can write like this, root 7. Okay. 2 times means degree 2. This is root 5. Square is going to be 5. So on you can write down. Okay. So 7 is root 7 into root 7, which we can write root 7 whole square. This way you can take any number, but 2 roots value will give you one whole number. So now that I am going to explain here, 2 is a whole number. This is root 7. This is 7 into root 7. So this will be cancel out. Now the answer is 2 by root 7. Now for that we have to perform the division method, as I told you that when in the denominator we have a prime number, always it is non-terminating number. But we cannot say whether it is a non-terminating recurring or non-terminating non-recurring. For that we have to perform the division method. So for that, suppose small division method we do 7 ones are 7 twos are 14. Okay, 6 is there. Then 7 sevens are 49, 7 eights are 56. So 4 will come. Okay, again 7 fives are 35. So again 5 will come. Okay, then we continue this method. So 7 ones are 7 sevens are 49. So 1 will come. 7 ones are 0.2857. Now 7 ones are 7. 3 will come. Okay, so 7 fours are 28. Again 2k. Okay, so now again 2k means the process is stop. So it is 0.285714 and then again it repeats. So this is non-terminating but recurring value. So this is rational number. Okay. Now we move to the fourth one. Okay. So fourth one, that is 1 upon root 2. Now see here, simple method I am going to use. This is rational but this is irrational number. So when we divide any number by irrational, it is always irrational. So we can write this is rational divided by irrational. So for that I am not going to perform any of the practical sum. So I have already divided. I have already given example. So the answer is always irrational. It may or may not be irrational, but no, I told you when you divide rational by irrational, then it may or may not be rational. But in this case 1 upon root 2 is irrational number. That depends on the given answer. Now next sum will do. This is 2 into pi. As I told you, this is whole number. Pi is a irrational number. Okay, so that is why when you multiply 2 into rational, this will be also going to be irrational